Welcome to our presentation. We are MIT boys and we have taken up challenge number 3. So now we come to our problem statement. That is to programmatically create a 3D track using BPY, the Blender Python API. The script needed to be scalable to fit any track across the various countries where F1 races are hosted. So that is what we set out to do. How have we done that now? Using the directional and geographical data of a racetrack, we have written a BPY script to generate a 3D model of that racetrack and then modified it to make it scalable across any track coordinates. With the advent of the Metaverse and the VR experience, we believe it is of utmost importance to be able to programmatically achieve the modeling process that would otherwise have required manual work.
As you can see, this is how the flow of data occurs in our 3D modeling process. You would first be given F1 track data in the form of geometrical coordinates, and after we extract this directional and positional data in the form of JSON, we would plot this data as a polyline curve. The next step would be to convert this to a skin mesh and then adding some texture and shaping to it, eventually obtaining the 3D track model. Additionally, we would place curves and tires and various other objects beside the chicanes. We would also place the optimum racing line to give it a gaming feel. Scalability and usability. The solution we have implemented generates an output that is ready to be 3D printed and is highly scalable to suit almost all track data coordinates. Some of the use cases include enriching viewing experience for the fans so that they can view a race by being a part of it rather than just looking at it through a screen. F1 teams have been moving towards VR experiences, and these models could serve as foundations for them to ideate and create experiences. F1 teams can also render such models to launch or display their cars during their car reveals.
Let's talk about the main tech frameworks used in this project. The most important one is the Blender Python API, which basically allows us to run Python scripts within Blender. Next, we use general HTTP services for extracting the track data from the Hackmakers web deployed API. Finally, we use the Oracle Cloud infrastructure. Let me elaborate a bit on that. The Oracle Cloud infrastructure offers a wide range of cloud services that enables us to build and run applications and services. One of the services offered by OCI is high-performance compute capability, like physical hardware instances. Hackmakers were kind enough to let us use one of their virtual machine instances as a render farm. This high-quality render was done on an OCI instance, allowing us to reduce the render workload on our own devices.
With the Metaverse, all across sports we can see teams give their loyal fans a once-in-a-lifetime opportunity to be involved with the whereabouts of their favorite teams. We saw McLaren launch their car on the Metaverse this year. But the business point of view that we propose here is to give fans much more than that. We want a fan sitting in Sydney, Australia to have a complete experience of a race in Monte Carlo using our script and VR. And our aim is to bring the model as close to real life as possible. And what's exciting is we have a plan for this. As we go deeper into the information age, and as there's more data available to us, we can think of a number of ways of enhancing the user experience. This ranges from data about the weather on the race day to data about the skyline around the track. Rain during a Silverstone race or a familiar skyscraper in the Abu Dhabi skyline will definitely add to bring about a holistic user experience.